So we're especially interested in functions. We're especially interested in relations that are described by an equation, which raises the question, how do we recognize that a relation described by an equation is a function? Well, take a look at this relation. We notice that here our y value is given as an expression in our x value. So in other words, we notice that if we plug in a value for x, we just need to do a bunch of arithmetic, and that will just spit out the value of y. And because when we do arithmetic, it works out the same every time, that y must be the same whenever we plug in the same x. So the way that we can recognize that this equation describes a function is that this equation is solved for y. In other words, it's written in the form y equals some expression in x. And whenever that happens, we know that we have a function. Let's see what we need to do in order to evaluate that function. So if we want to find, for example, f of 2, we need to find the value of y when x equals 2. Well, we know what to do. We're going to take 2 and plug that in for x. So we'll have y equals 2 squared minus 5. Oh, well, I know how to do that arithmetic. So that's just 4 minus 5 equals negative 1. So f of 2 is just negative 1. To find f of negative 3, well, we want to find y again when x is negative 3. Plugging that in, we get y equals negative 3 squared minus 5. Again, I know how to do that. That'll be 9 minus 5 equals 4. F of negative 3 is just 4. What about f of 0? Again, we want to find y when x is 0. Plugging in, y equals 0 squared minus 5. And again, we know how to do that arithmetic. 0 minus 5 is negative 5. When x is 0, y is negative 5. So f of 0 is negative 5. So we see this pattern, right? Whatever our input is, whatever our x value is, we plug that in to the right side of the equation. We do the arithmetic. That spits out our y value, which is what f of that x value is. And so this gives us a convenient way to describe functions. It gives us a shortcut for describing a function if we want to describe it in terms of an equation. If we write f of x equals some expression with an x in it, that's the same as writing f is the relation that consists of the pairs x and y such that y equals that expression in x. So we can write f of x equals an expression with an x in it to describe a relation without going to the whole relation notation. So as an example, g of x equals negative 5x plus 3. That means that g represents the relation consisting of all the pairs x and y, such that y equals negative 5x plus 3. So for any input x, the corresponding y is found by multiplying by negative 5 and then adding 3. To evaluate g of 4, right, we want to find y when x is 4. So we say negative 5, replace the x by a 4, plus 3, and then we know how to do that arithmetic. Negative 20 plus 3 is negative 17. G of 4 equals negative 17. Notice that I've been kind of changing how I write the names of relations. When we were talking about relations and thinking of them mostly as sets, we were using capital letters from the later part of the alphabet, capital R, S, T, and so on. When we're thinking of them as functions, and when we're thinking of writing functions, especially in terms of equations, we tend to use lowercase letters from the beginning of the alphabet, F, G, H, K, and so on.